pKa value of a weak acid. It is an experiment which is very, very important, and it helps students a lot in finding the pKa of weak acids. Remember, we always find pKa for the weak acids because they get partially dissociated. So that is why it is very important to find out the pKa for the weak acids. So let's try to understand. Let's set up an experiment where we have the pH meter, which will help us in finding out the pH values, and then we will calculate the pKa value by the data that we will get from the pH meter. In pH meter, we are going to use a glass electrode which has the sensor, and that will help us in finding out the pH values. So let's set up an experiment where in a beaker we take the weak acid. Say we have taken acetic acid over here, and in the burette we have filled up the base, which is our standard sodium hydroxide. So as soon as we will start adding NaOH to the weak acid or the acetic acid, what will happen? The acid will start getting neutralized by the use of sodium hydroxide. So what happens with the help of Henderson and Hasselbalch equation, we get this equation over here, which is pH is equal to pKa plus log of concentration of salt upon concentration of the acid. Salt, which is going to form when we will add the base to the acid, and acid will start getting neutralized. So remember, as we keep on adding salt, no, sorry, we will keep on adding the base to our acid, the concentration of acid will lower down and the concentration of salt will be visible there in your solution. So pKa is basically, we determine the pKa value by measuring the changes in the pH of the acid solution at different amounts of base we add, right? So what we can do with the help of this equation, what I can say that if this value becomes 0, if this value becomes 0, what I can write, I can write pH is equal to pKa, because this value became 0. When it will occur? It will occur when the concentration of salt and the concentration of acid will be in the equilibrium. So when the concentration of salt and concentration of acid is equal to each other, we can write this very confidently that pH is equal to pKa. So say for our example, we had taken acetic acid. So if we can write our equation as pH is equal to pKa plus log base 10, and which is our salt here? Which salt is forming? It is CH3COO Na divided by our acid is acetic acid CH3COOH. So we can write this equation on the basis of our selected base and the acid. Now if the concentration of your salt is equal to concentration of your acid, what you can say? You can write pH is equal to pKa. That means now when in the pH meter, when you will measure the values, right? So those values of the pH will help you in finding out the values of pKa. So this is very important over here, that at this point we can say when you have the concentration of salt is equal to the concentration of your acid, you can say that pH will be equal to pKa. Now let's move to our data which we have got it from this experiment. We have taken this experiment, and on the with the basis of pH meter with the glass electrode, we have calculated the values of the pH. So this is basically the titration data, right? What we do, we take an acid in our beaker and we keep on adding base with the help of burette, and we keep on determining the pH value, measuring the pH value at each 0.5 ml that we add to this flask, and that will give us the value of pH. For example, when we will begin from here, at this moment, when you, since it is an acid, so say it starts from like 1.23 or say, and as soon as you add, then you will measure the pH over here, then you add 0.5 ml, then again you measure the pH. So you keep on adding the zero point 0.5 ml of base, and you will keep measuring the pH and noting down in this table, right? So your table will grow like this, and you will observe and pattern that what will happen. Initially it will increase very gradually, very slowly, but when you get the point of equivalence, what happens, this value suddenly exceeds, and say it around reaches over here around 10 or say something, right? And after that you will just take 3 or 4 values more, and that becomes almost straight or almost stagnant, right? So what is our target over here? We need to find out the pH right now when we add zero point 0.5 ml interval, right? We are adding a base at zero point 0.5 ml interval to the beaker, and we get the values over here. So initially the values will increase gradually, and at we will get a point where there will be a sudden increase in the pH value. So we will have the data now. Now having this data, we will see that how it helps us in calculating the pKa value, which is our objective. So let's see in next column what I have taken. I have taken delta pH upon delta V. So the change in the pH values divided by the change delta V is nothing but, for all the stages, our delta V is zero point 0.5 because we are adding the base at the interval of 0.5 ml, right? So now what will happen? You will just calculate the delta pH upon delta V. How will we do it? For example, here it becomes delta pH means this minus this. So 1.67 minus 1.23 divided by zero point 0.5. So this will give you this value. Then you keep on calculating this value like this over here, and you will complete your table, right? Now we will plot two graphs over here. Graph number 1 is you have volume of NaOH at x-axis and delta P upon delta V at y-axis. Now just plot a graph. Now just give attention over here. You have taken volume of NaOH at x-axis and this at y-axis. Let me choose another color. Yeah. x-axis and you have taken delta pH upon delta V at y-axis, and you have plotted a graph. You will get a point, a certain point where your peak will be there. So you will draw a line over here and you will get a point at your x-axis, which is basically the equivalence point, which is the equivalence point. Say this is around 6 ml. So suppose this is your 6 ml is your equivalence point. What is equivalence point? Equivalence point is one where complete acid is neutralized. So equivalence point is nothing but where complete acid gets neutralized. This is very important concept. Let's try to understand, and you will never forget this calculation part if you understand this properly and if you pay attention over here, right? So now the next important thing is, now we have got the equivalence point, which is 6 ml, right? So the value corresponding to this will be here, nothing but the value where the complete acid has got neutralized. Okay, now let's look at the second graph. The second graph says that you have volume of NaOH at x-axis, and now what I have taken pH at y-axis. So now what changes? The change is you have taken volume of NaOH at x-axis and pH value at the y-axis. Let's plot a graph over here. So as you can see, this gradually increases first. As I had mentioned that these values will gradually increase. So it increases slowly and then there is a sudden rise in the graph, and then after 3 or 4 values it almost becomes stagnant, right? So you have got the point of equivalence somewhere in between. Now we know that what is our equivalence point. Our equivalence point is this, where we have got 6 ml. So we will look at the point where the half neutralization is done. So half neutralization will be done at 3 ml, right? Because equivalence divided by 2. So we have got 6. So we will do divided by 2. That means 3 ml. So let's look at this. We have, suppose over here, the values, and in our graph suppose 3 ml comes here. So let's plot a line over here and we have got this. So this is nothing but the, now we have got this one is the half equivalence point. Half equivalence point is nothing but where half acid gets neutralized. This is very important, very important, that now with the help of second graph we have got a point where half equivalence point has been found. Now let's look at this. The value which is corresponding to this, the value which is corresponding to 3 ml, that means the half equivalence. Half equivalence point is where the salt concentration and acid concentration is equal to each other. That means this phase. So when at the half equivalence point, the concentration of salt and concentration of acid becomes equal. What we can write? We can write pH is now equal to pKa. So now you have got your pKa. Which one? The pH is equal to pKa. That means this value, which is corresponding to the 3 ml of NaOH, is the half equivalence point, and this value is nothing but, this value of pH is nothing but the value of pKa. Isn't it interesting and easy? So stay tuned for more such interesting and easy calculations with me. Okay? Bye. Please subscribe to my channel and like and share this video. Thank you so much again.